Question 8. With a logarithm bit going on with it, we've got two curves, log base 2 of x and log base 2 of x minus 3. And the first bit describes the geometrical transformation that transforms that curve to that one. Well, we know about this, it's just one of these standard things that we've learnt what these transformations do. It's the f of x plus a bit, it's the bit inside the bracket. So we've got to make sure that we use the correct words for all of this. We're going from log base 2 of x to log base 2 of x minus 3. So that's a side-to-side transformation. So we need to get the word translation in there. Okay? And we need to make sure that we've now described this correctly. That is 3 units. And we need to give an accurate description of the direction. So it's 3 units in the positive x direction. Okay, and there needs to be this description of the direction and a sense of positive or negative about it. And so that's for the second mark, you have to look for that. The first mark's really just for the word translation. This is the one. Was this Henry? You need an extra mark for this, don't you? Because I missed your positive being in there. Part 2 says the curve y equals log base 2 of x passes through the point a3, stable value of a. Well, this is just. Can you remember what logs is all about? If it passes through the point a3, that means that when x is a, y is 3. So when x is a, log base 2 of a, equals 3. We know how logarithms work. This means 2 to the power of 3 equals 8. So a equals 8. Really nice, gentle 1 mark for that. Part 3. Gentle? I don't know. Part 3, the curve y equals log base 2 of x minus 3 passes through the point being 1.8. So this is the other way around now. We're told, oh no, this is the same thing. We're told the x value, we need to find the y value, but it's not so nice numbers. We want an answer to 3 significant figures. So this time, log base 2 of b minus 3 is equal to 1.8. So we're going to apply the same step to that. We're going to say that 2 to the 1.8 equals b minus 3. So b is 2 to the 1.8 plus 3. Dive to the calculator, and your calculator should say 6.48 to 3 significant figures. Okay? Now, the question gets really interesting. The point P lies on y equals log base 2 of x and has an x coordinate of c. The point Q lies on it, on the other curve, and also has an x coordinate of c. So their x value is the same. They're vertically above each other, these points. Given that the distance PQ is 4, find the exact value of c. Okay. We've just said that the second one was a translation 5 units to the right, 3 units to the right. So when we have this described here, we've got the point P. This is the curve log base 2 of x. So P is somewhere like there. Q has exactly the same x coordinates, so Q is underneath it there. And that distance, represented by that green smudge there, is a distance of 4. Okay? So what we want to do now, if we forget about x values, this is the x value of c, if we subtract the 2 y values, it equals 4, because their distance is 4. It's quite nice that they're vertically above each other, because we don't have to do the whole Pythagoras theorem distance between 2 points. It's just the difference between their y values is 4. That's what the question has told us. It takes a bit of doing to get actually that out of the question. So the distance in the two y values is equal to 4. The difference of the y values is 4. In other words, if we do log base 2 of c, that's the upper one, that's the first curve, take away log base 2 of c minus 3, that gives us 4. Now you really had to get that equation set up before anything else could happen. Now you can demonstrate some of your amazing knowledge of logs. If we subtract two logs of the same base, then this will give us c over c minus 3. If we then unpick the logarithm, we've got 2 to the 4 is c over c minus 3. So 2 to the 4, 2, 4, 8, 16. If we multiply through by c minus 3, 16 lots of c minus 3 is equal to c. Give you a 16c minus 1 here. Thank you. Is c. So 15c is 48. So c is 48 over 15, and we're going to leave that in its simplest term, and we could leave it like that, or we could divide through by 3, couldn't we, to get 16 over 5, and there it is.
Seems really easy.
Okay, that, once you get from there onwards, it's alright. The tough bit, the key to that question was all about could you unpick enough of the words to get that line there. And if you got that line, everything else was going to be okay, but that was the hard bit. Could you get that line in the first place? And it was all about working out what this stuff all meant in terms of the diagram. Remember, if you want to, you can make a few little notes on your diagram of the paper. This is yours to make it work for you. So if you need to write on your diagram to make it work for you, then do that. Okay, you can scribble on it as much as you like to. You might annoy your maths teacher who wants to use it as a mock paper the following session, but go for it. Great. Thanks, Tom. You can stop the video whenever you like.